We all know plastics, right? Like plastics are big pieces like we use every day. And the nano and microplastics are just the small particles released from this big plastic debris. We know that like every year there are over 22 million pounds of plastics ended up in the Great Lakes. And these plastics like might generate some nano and microplastics.
What we care about here is very small macroplastics. So you can think it's smaller than common bacterial cells. For nanoplastics, it's smaller than virus cell. The plastic itself is pretty inert because it's the polymers, right? But sometimes surface can get oxidized, which can capture or accumulate the pollutants in water and make it toxic.
So I plan to work with Dr. Wei to develop a new and efficient analytical method like to detect and quantify what we call it as nano and microplastics. Currently, there is no very efficient technology to do this. The question we want to answer is how much will be released from this plastics debris and how long it would take. In general, membrane is widely used for particle separation and water filtration processes. My role for this project is try to develop a membrane technology to do this. The membrane process is served as a pre-concentration and a separation process like for different size ranges of microplastics. And Dr. Wei will try to use like what I collected and separated like from this membrane process like to do the analytical detection of these microplastics.
The Raman spectroscopy is used to identify the polymeric composition of this micro and nanoplastics. We have thousands of plastics, right? We have the plastic bottles, the plastic packaging we use in the fast food restaurant. Different plastics have different surface chemistry and they can undergo different degradation pathways in the water. So that means they could have different toxicities. To figure out what the sources are, we need to know exactly what's the composition of this. The exciting thing I look forward to see is whether the surface-enhanced Raman spectroscopy can improve the scanning rate by 1,000 times or higher. This could be a game changer of the macro nanoplastic analysis, right? So you can generate large data sets within a short time period and with a very low cost using that method.
I think the most challenging thing would be dealing with real lake water. Even though we think that it is very clear, still like there are a lot of like microbes living in the lake. So it is hard to differentiate like these particles from like some organic compounds. I am confident that like the method Dr. Wei and I developed like will do this job, but we still feel that it is still very challenging. Yeah.